Alright guys, now that we understand what quantum numbers are and how we can calculate them, let's go ahead and figure out the quantum numbers for the first two energy levels. We'll start with energy level 1. Why not? It's the smallest energy level, the one closest to the nucleus. So at energy level 1, we need to figure out how many different shapes we can have. Well, in order to do that, we get a range of values, 0 to n minus 1. So we always have 0, because it says we can, and now we need to figure out n minus 1. So if we took a look at the n value, which is 1, and subtracted 1 from it, it would be 0. So 0 to 0 is 0. Basically, we can only have one shape at the first energy level. Now for the notation, what you basically do is you write the n value and then the L value. However, you write the n value and the L value has a corresponding letter to go along with it, and for 0 it's S, which basically means spherical. Now, if you don't know what letters I'm talking about, go ahead and watch my tutorial. I think it's like 2 tutorials ago. I talk about the L value and how it can, I pretty much explain it. So now at this energy level, we need to figure out how many different ways we can tilt this shape. Now, the different tilts are based on the shape itself, and the range is negative L to positive L. So if you look at L, it's 0. So negative 0 to positive 0, well, that's just 0. So go ahead and write 0 right here. What this is basically saying is, okay, you can only tilt this. It's basically stuck in the same orientation forever. You can't tilt a sphere or a ball in different directions. And for this electron spin, this is an easy one. It's always going to be negative 1/2 or positive 1/2. Basically saying in this energy level, or this shape right here, we can have two electrons. One can be spinning counterclockwise and one can be spinning clockwise. So that's basically what we're saying. In the first energy level, it can only have one shape. Here's the name of it. You can't tilt it at all. It's stuck in the same place forever, and it can have two electrons, one going counterclockwise and one going clockwise. Simple enough. So now let's go ahead and get a little more complex and figure out the quantum numbers for the second energy level. This one's a whole lot more fun. So at the second energy level, we need to figure out the different possible shapes it can have. So we go ahead and we always have 0, so that's one shape, and it's spherical. And then we figure out, okay, we get the range of n minus 1. So 2 minus 1 is 1. So we have 0 to 1. So that's our range of values. So now we go ahead and write the notation, which is, remember, the n value and then the L value. So for this one, it's 2s. And for this one, the n value is still 2. And the 1 is p. So this pretty much means a bigger sphere and a big in p. The p shape looks like two balloons pressed together. So now we need to go ahead and figure out for each subshell how many ways can we tilt that shape. So negative L to positive L, the L value for this is 0. So again, 0 to 0 is just 0. And that is because you can't tilt a sphere in different ways. No matter which way you tilt it, it's always a perfect ball, basically. Now for this one, 2p looks like two balloons pressed together. So how many different ways can we tilt this? Well, negative L to positive L, we have negative 1, 0, and 1. I won't write positive 1. So basically, in the 2p subshell, we can tilt that shape in three different ways. So for this one, again, the electron spin, we have negative 1/2 and positive 1/2 for the 2s orbital, or the 2s subshell. And for 2p, each of these can hold two electrons. So 1/2, positive 1/2, negative 1/2, positive 1/2, negative 1/2, and positive 1/2. So if we take a look, here's what we're basically saying. In the first energy level, we can only have one shape. Now, in that shape, we can have an electron spinning clockwise and counterclockwise. So we can have two electrons in the first energy level. And if you remember, that's what Bohr agreed with. In Bohr's model, he said the exact same thing. The first energy level can hold two electrons. This is just a more sophisticated model. So first energy level taken care of. Now in the second energy level, we can have basically two different shapes. We can have a sphere and two balloons pressed together. Now in the second energy level, we can also have 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. So the first energy level can hold 2, and the second energy level can hold 8 electrons. Pretty cool, huh? And remember, that's what Bohr said. The first energy level can hold 2, the second one can hold 8, and that's true. This is just a more sophisticated way of figuring that stuff out. So for the third energy level, I'm going to leave that up to you guys. The first person to comment and figure out, here's the question of the day. Here's your homework assignment. How many electrons can you have in the third energy level? And once you figure that out, leave a comment below, and the first person to get the right answer wins. I don't know what. I don't know. I'll say congratulations to you or something stupid and ridiculous. So anyways, thank you guys for watching. Hopefully you figure out now how to figure out the quantum numbers and hopefully what they mean. And in the next couple tutorials, I'm going to be making this even more simple until the picture is crystal clear in your head. So now that you know how to figure them out, go do your homework. First person to come up with the answer wins. So thank you guys, and I will see you guys next time.